This is a presentation that we put together for the open house last year. With the COVID, we usually have an open house in August, mid-August every year around the Perseid meteor shower. And last year we weren't able to do it, and we kind of hemmed and hawed throughout the year. And we finally decided just to do a virtual presentation. And so this is basically that presentation, updated a little bit since we gave it, but that's what it is. Ray and I have both been presidents of the organization, so we're going to do this together. So who are those guys? What are they doing down there in Haswell, Colorado? Well, for more information than I'm going to give you, you can go to DSES.science. And we publish almost everything we do. And so everything that we've done in the last probably 6 years is published on that website. So our charter is the Deep Space Exploration Society is a Colorado-based nonprofit 501c3 organization. It's dedicated to practical astronomy, space science, and radio education for students, the general public, and society members. We own and operate a well-built 60-foot radio telescope dish in Kiowa County near Haswell, Colorado. It's about 5 miles south of Haswell. So I'm going to stop there. Can everybody see the presentation okay?
All good.
Okay.
Yep, you're good.
But I'm not leaving you in the dust here. Okay, so the history, there were twin 60-foot parabolic dish antennas near Boulder, Colorado, and then the 60-foot dish in Haswell. These were all identical dishes, and they were originally part of a network of sites built for the National Bureau of Standards, which is now NIST, for their Central Radio Propagation Laboratory to study tropospheric scatter propagation sponsored by the Air Force. So the antenna sites were located from Colorado to Arkansas. The goal of the original study was to compile a standard communication handbook of accurate reference materials so that any group that desired to establish such a communication system anywhere in the world would have all the data necessary for the site selection and construction. The study of the sites lasted from about 1958 to 1974. The information gathered supported communication systems for the distant early warning radar, or the DEW line. The Haswell site construction was underway in late 1957. Part of the land was apparently leased, but then they expanded and purchased an intimate domain by the government in 1963. They actually bought the land where the site sits. The Haswell site was operated until about 1974, when it was made obsolete by satellite and fiber optic communication and was abandoned and surplus. So for those of you that don't do tropospheric scatter, this is kind of the idea. They have a station over here, transmitting station T1, putting microwave beam up into the atmosphere, and the particles in the atmosphere reflect part of that beam, very, very small part of that beam, and then at some distant station around the horizon, you could point a dish back at that area of the atmosphere and pick that up, and then you could repeat that around the globe, and so you could get pretty long distance communication at microwave frequencies. As with many of the government programs, little expense was spared in achieving the program goals. For example, the original specification for the 60-foot dish stated the maximum deviation of surface from the true parabolic shape shall be no greater than 1/4 inch at any point on its surface. This parabolic reflector is to operate with full precision 1/4 inch in winds up to 30 miles an hour, and slightly reduced precision 3/4 inch in winds up to 50 miles an hour. And the reflector, when it's properly secured or stored, and we call it the bird bath position when it's pointed straight up, shall be capable of withstanding winds up to 120 miles an hour with a maximum radial ice formation of about 3 inches. Well, that sounds pretty extreme, but the environment in Haswell and in Boulder and wherever else they were going to place these dishes could easily be that extreme. So that was their idea. They didn't want it to break. Here you can see Ray standing in the dish and the superstructure underneath. This is heliarc welded 10, 8, and 6 inch aluminum tubing. and it's beautifully welded. The whole structure underneath is quite the thing to behold. The surface has this perforated aluminum. Somewhere here I have the aluminum. I don't know. I didn't put it on this slide, but these are 1/4-inch holes, and they're spaced out about maybe 3/4 of an inch. And you can walk on this surface and not distort it. It's about 3/16 thick. And so it's a pretty secure thing. This thing has sat out there in the prairie for, oh gosh, 60 years, more than 60 years. And it has virtually no damage from the wind and the hail and everything else that happens out there. Here's Ray working on one of the struts that holds up the apex where we put our feed antennas. So the dish has a frequency range about 400 megahertz to 2 gigahertz, and we can possibly go to 10 gig, and we're going to try that probably this year. It's 60 foot in diameter, has an antenna gain of 42.5 dBi at 1 gigahertz, a beam width of 2.6 degrees at 400 megahertz, 0.8 degrees at 1.2 gigahertz, noise temperature 1 to 2 dB at 400 megahertz for the total system, and a noise figure of 0.8 dB at 400 megahertz with a 20 dB LNA at the apex. The original requirement was for the dish to slew in both azimuth and elevation at 40 degrees per minute. We've replaced the motors, and I think we can probably easily do that still, even with the new motors that we have, but they had a completely different motor system when they constructed it. Any questions on the dish so far? Okay, I'll go on to the history of the org. So the DSES organization was originally formed in 1991 in Boulder County. The members started restoring the twin 60-foot parabolic dish antennas at the T-22 site on North Table Mountain, about 10 miles north of Boulder. There was considerable success with this facility using the talents of professionals and university students in the area. And unfortunately, Table Mountain is a secure government research site, and after 9/11, a more conservative management closed the site for amateur use. The DSES needed to find a new home. So let me tell you a little bit about Haswell. The Haswell site lay dormant from 1974 to 2009 and fell prey to the elements, vandalism, theft of much of the infrastructure, copper. The original large 3-phase overhead power lines were removed to better facilitate farming around the site. So it was really laid to rest and just waiting for something to happen or somebody to tear it down. And sometime during this period, Paul Plishner, a prominent radio and radar contractor with the government, purchased the site from the government auction. Probably realizing the impracticality of restoring this site, he offered it for sale for several years, but he found no buyers. In fact, Ray's group tried to bid on it when Paul was bidding against it, and they didn't get it. But this was one of those things that was up on a government flyer for government surplus auction. So when the DSES group had to leave Table Mountain, they asked Mr. Plishner if they could be the custodians of the Haswell site and do some restoration. He agreed, and they moved the operations and communications trailer and some of the equipment to Haswell. If you look at this is a photo from 1972. See the dish there on the left side with that large radio tower, about 500 foot. That was used for other VHF and HF propagation studies, and that has since been torn down. You can also see 3-phase power transformers on the poles there. Those were missing. That's all been taken away. So the only thing really left was the bunker that I'll show you and the dish. So in 2009, our member volunteers, they've been working hard to restore and modernize the antenna and its facilities. And after making a lot of progress on restoration, Michael Lowe, the group president at the time, asked Mr. Plishner if he would consider donating the dish to the DSES organization, and he did. And so for this generous donation that he made, the site was named the Paul Plishner Radio Astronomy and Space Sciences Center. Mr. Plishner passed away in November of 2016, but his generosity is still greatly appreciated by the organization. His legacy will live on many years at the site as the site is brought to full operational status as a science discovery and educational center. Now, power. Because the site had no utility, the power poles had been taken out. We needed power to power our electronic sensors, our computers, our lights, our sump pumps, all the things we needed to run this facility. And so we installed several solar power systems. Most of those were about in the 400 watt range. There's a battery bank in the bunker that we use for our sump pumps. We had solar panels on the communication trailer and railroad batteries that we used for all of our experiments and our lighting. And that's how we did it. If we needed something more to run the dish, we had a backup generator, 25 kilowatt propane generator. Ray got this as, I don't know, Ray, did you get this generator off the mountain, or was it only the propane tank? I can't remember where we got the generator.
Actually, the generator came from one of my AM stations that no longer used it in Colorado Springs. That was hauled out, and then we got the 1,000-gallon propane tank from on top of Cheyenne Mountain that had been abandoned.
Yep. So Ed Korn, Steve Plock, Michael Lowe, many others, Ray included, spent many long hours installing electrical wiring and fittings to make the site operational. And when dish movement was required, we had the 25 kilowatt propane generator available. But that generator cost us more time than just about anything at the site because it was constantly breaking down. In April 18th of 2015, we trenched over 600 feet for power cables, control cables, and coaxial cables. And there's the picture of the trench going out to the dish pedestal. Now in 2018, Skip Creeley, he's a prominent RF entrepreneur. He's had several companies that he's owned and started up and sold. And he generously donated the money to bring in a single phase power line over a mile to the site. And all you broadcast engineers know how difficult that is to get power into a site, you know, if you have a remote site. But once that was attached, we had abundant 230 volt split phase power. We could spend a whole lot less time maintaining the solar panels and the batteries and the generator, and more time on radio experiments. So thank you, Skip, for that donation. So our accomplishments to date are the solar power systems, the generator, the UPS, electrical infrastructure throughout the facility. It all had to be rewired because all of the copper had been torn out of the facility and we had almost no electrical. Utility power was restored, emergency telephone was installed. We now have an internet connection that we just got put in, dish motion controls, the dish celestial and moon tracking capability, antenna feed with fiber optic and coaxial connections, restroom facilities, underground facilities restoration, sump pumps. We have a 146.46 talk-in radio that we can call in if we get stuck in a ditch. The Raster radio astronomy software-defined radio, and feed antenna construction for 408, 1420, and 1296 megahertz, and many other things that we've installed at the site. Ray just finished a antenna and a flex radio setup for Radio Jupiter for signals off of Jupiter. Let me jump to the dish motor controls. Any questions so far? Okay. Glenn Davis, Dave Moulter, Phil Gage, and others designed and built a System 1 dish positioning system based on a Raspberry Pi and a PC running Unix. And then Ray Johnson, Ray Ubrecht, and Bill Miller built a System 2 controller based on a Winford data acquisition system and a PC running Windows. So there's two different systems that we built for dish controls. We kind of had a runoff between the two. And it looks like System 1 kind of won out. We had both systems operating. Both were capable of driving the dish and doing tracking. But we had a problem with the Ethernet connection with Windows on System 2 and had a little bit of problem with the thing just kind of going off in the weeds on us. And so we're still trying to figure that one out. But we do have System 1 operating. In fact, we're in the second generation of System 1, and all of these parallel to serial encoders that were in that system to feed the Raspberry Pi have been replaced with a shield on top of the Raspberry Pi that is a parallel to serial interface for the Raspberry Pi. So,
hey, Bill.
Yeah, go ahead.
Actually, I wanted to ask, is your control room, your control center, you trenched that big long ditch for everything. Do you stay far away from the dish, as far away as is practical, to reduce other RF noise around the dish? Or why wouldn't you build the control room right at the base?
Well, that's part of it. To get out of the way of the feed antenna and its shadow into the dish, because there's some spillover. That's part of it. But part of it was, I think it's the placement of the trailer was very difficult to move because it was tied down with cables and foundation supports to keep us out of the tornadoes. But yeah, we've got about, I think, what is it, 60 feet from the control trailer to the dish pedestal.
Yeah, it's a little bit longer than that actually, because but it's not a lot. But that's where our predecessors, the guy that first went down to the site and got it, a bunch of people out of the Boulder area and Denver, Boulder, Fort Collins, Longmont area, they actually moved that trailer down there. They got it from Boulder and moved it down there and put it in place. And none of us has the ambition to want to move it, but it's far enough away from the dish, because you remember, if you tilt the dish all the way over to the horizon, the bottom of the dish will hit anything very close to it. So we had to be far enough away, and that turned out to be the trailer that's 60 to 100 feet away. Total feed line length, which uses half-inch heliacs, actually is about 210 feet all the way up to the feed. But so that's where it currently sits. But we're somewhere in the vicinity of 75 to 100 feet away.
Okay, very good. That answers that. Thank you.
I'm going to attempt to play you a video. I've had trouble with this all day. I've been trying. Let's see. I want to make this big. There. Okay. Can you see that image?
Yeah, it's good.
Okay. Can you hear it?
Firm.
Okay. Yeah, I had trouble with the audio. Something I discovered about Zoom, for all you Zoom people out there, if you have your headset plugged in and you try to play a video off the internet or from the PC, you'll lose the audio in some cases. And so I struggled with that. My daughter, who's a teacher who's been using Zoom all year, I called her just before the meeting and she walked me through it, and we finally concluded it was I had my headset plugged in. So if you have trouble with the audio, try unplugging your headset. Anyway, I'm going to play this for you. It's about a minute, 2 minutes long. This shows you the dish movement capability. Okay. So you can see there, this is courtesy of Mark Slover. He's a time-lapse photographer. He has a website called Road Trip Ventures on YouTube, and he loves to take things like this and windmills and all sorts of things and do stop motion and time-lapse video. One thing you'll notice about that movement is that it wasn't perfectly smooth. The dish cogs or jerks as it moves. And the reason for that is we don't have enough torque in the motors to drive a continuous, very slow movement. And so what we do is we lead the object, let the object fall through or drift through the field of view, and then we drive it again. And so when there's an error over a certain amount, then the dish drives. So you see a kind of a choppy motion. It would be nice to have a very smooth motion, but with the way the gearing and the motors are set up, we don't have that capability.
Hey, Bill, Amanda asked, what are the counterweights on the dish made from?
Well, I think they're lead and concrete. I looked at it and I said, if they were just concrete, it wouldn't be enough weight. But we understand that the dish is about 65 tons. And so you have to counter that, that mass with the counterweights off of the axle. And so they look like they're coated in concrete. It's like a basket of concrete. But I'm pretty sure that there's more to it than that. And I think there's lead in there as well.
Okay, go ahead.
Let's move on to the underground. There's Ray. Back in 2014, one of the first visits that he made down to the site. And that's what happens after all winter with the tumbleweeds. We have tried everything under the sun, hurricane fences, coverings, everything possible to try to figure out how to mitigate these tumbleweeds, but nothing seems to work. If you notice, on one side, we have a wall. This is the ramp that leads down into the bunker. We call it the bunker or the underground. And that ramp was made so you could back a truck down this ramp and unload equipment or load equipment down into the bunker. Someone tore down one half of the wall here, and so this wall erodes and mud rolls down into the bunker and up against the door. And so between the mud and the tumbleweeds, it's quite the undertaking. We've tried everything we can think of to get these tumbleweeds out. The thing I did lately was I made a basket out of a tarp and loaded the tumbleweeds onto the tarp and rolled it up with a rope and just drug it out. And that seemed to be the easiest way to move the tumbleweeds out. But this is quite a mass of tumbleweeds. There is a door down there behind Ray, and you can't see it. And down that door is this hallway on the other picture, and it leads into this room. We probably have about 1,500 to 2,000 square feet of space down in the underground. And so there's plenty of space to, a little kitchenette down there. We have 3 containers, 500 gallons of water. We have a machine room, a ham radio station. I'll show you that in a minute, and quite a number of things. And also there's a bathroom and a battery room and storage room where we can have the batteries for the solar system. Like I said, that wall got torn down, so a few of the guys said, well, let's shore that up. So they rebuilt another wall in front of it and started that, and that worked pretty good for about 2 years. And then the erosion from the hillside overcame that wall, and we still have mud running in. So we're going to have to build up the. So if anybody has some cinder blocks they want to donate, that'd be great. We could build up the wall and prevent the mud from coming in. One of the other things we did was build a spiral staircase at the opposite end of the bunker as a secondary egress to get out in case we had a fire, or if we had the front of the bunker completely obscured by mud or tumbleweeds. So we have a spiral staircase there that we welded in, and we can get in and out that way too. Oh, any questions on the bunker? Oh, one thing I should mention, there's we have two sump pump systems in this. And because of this ramp, there's a lot of water that comes down the ramp. It rolls under the door and it goes into a drain and into a vault. And there's a sump pump in the vault, and it pumps that water out at a pretty fast rate to get it out of our way so that the bunker doesn't flood. During the 50 or 60 years that this lay dormant, the water rose to a 3-foot level inside the bunker, and we can see that from the water line on the walls. Let's talk about feed antennas. So Ray devised this really interesting gadget. We had several iterations of feed antennas. The first iteration we had, Ray devised a 3-band all-encompassing feed that could be switched. And we tried to put that up there, and what we found was the complexity of that and the difficulty in mounting it made it kind of difficult to work on. So he came up with this other system that's a quick change mechanism. It's like a bayonet, and you have these this hinge on the aluminum shaft here for a feed, and you can just loosen this and move this shaft in and out. So you can take the shaft clear out and replace the feed with a different feed. What we've got here is the 1420 megahertz feed. 1420 megahertz is a prominent frequency for radio astronomy because that's where the neutral hydrogen emission is. And since most of the cosmos is made up of hydrogen, we can read the density of the area that we're looking at with the dish with this 1420 megahertz.
Hey, Bill, I've got another question. Do you have to manually change the feeds out up at that feed point, feed horn? Do you have to, you know, as in the picture on the right, Ray, yep, over there, you have to manually change those out?
Yep, I'm going to show you that in a minute. I'll show you actually change what it takes to change it out. This one here is we've got a couple of dipoles out in front of a ground plane. It looks like a Yagi, but what's actually on that is a ground plane mesh, and then these are little dipoles out in front, and that's our 408 megahertz feed, and that's for pulsar work. So when we try to detect pulsars, that's the best antenna for that. And then this one on the table is the 1296 megahertz. We use that for tropospheric scatter communications and for moon bounce communications. There's the 1296 on the table. And now we've got a 5 gigahertz feed. This is actually the feed out of a standard communication Earth station. And we're planning on using some of our geostationary satellites to get a very fine positioning on those and do a better calibration of our pointing. And there's the 408 looking into the dish from the apex of the thing through the 408 megahertz feed. So here I'm going to see if this works. Tell me, this doesn't have any audio, so I'm just going to walk you through it. Here's what it looks like to change out a feed. You have to climb the scaffolding, and that's about 3 or 4 stories tall. That's Ray there in the blue shirt. He's going to latch his harness on to the turnbuckle on the apex right there, keep from falling off. This thing is so sturdy, if he were to fall, it wouldn't even deflect the dish. It would just hold him. In this view, you can see the bunker down here where these 2 red trucks are up in the upper corner. And then the next building right there is the generator shack and the propane tank and our communication trailer. And then we come down to the pedestal and the feed. And over on the side here is an outhouse that we built for the facility while we're down there. Yeah, when you're up there, it can get pretty windy and it can get pretty hot. And sometimes when the wind blows from the south, I guess it's the southwest, because of all those holes in the antenna, it sounds like a banshee as the wind blows through the antenna. And it's very loud. And when you're up there at the apex, it kind of focuses all that noise right on you. But Ray doesn't mind that. All these guys standing around on the ground are there to catch Ray if he falls off. There you can see there's enough wind that the rope's blowing and the foot of the drone is coming into view because the drone's bouncing around pretty good. Ray said this was pretty easy until he had that drone off his shoulder there, and it sounded like a hive of bees buzzing around on his shoulder. I'm going to truncate that and go to the next one. Okay, so for radio astronomy, we have the high gain 60-foot dish. For hydrogen line, like I said, we use the 1.420 gigahertz density mapping of the cosmos. And then we got radio drove at 15 megahertz to 22 megahertz. And what this is there's natural radio signals that are generated in the plasma and the magnetic fields between Jupiter and Io. And when they're in a particular position, I think it's when Io is perpendicular to us, to Jupiter, we get a pretty strong radio signal. So we have a radio receiver that can receive that and plot it in a plotting system. Super SIDS is a sudden ionospheric disturbance monitor, 3 to 300 or 3 to 30 kilohertz, pretty low frequency, and that shows solar events and flares. Oops. And then for SETI, we use the 1.42 gigahertz hydrogen line frequency, and we look for signals around and near that what they call the watering hole, and that's a search for extraterrestrial intelligence. And we've actually done a collaborative effort with another dish in Green Bank at the Green Bank Observatory in West Virginia. And the idea here is to get synchronized signals from the two facilities that are 1,200 miles apart. And if we see the same signal at both facilities at the same time, looking at the same object, then it's something well outside of Earth orbit and Moon orbit. So it's probably something that's out there that we can't explain.
Hey, so Bill, why that particular frequency? Why look at the hydrogen line when you're searching for other intelligence? How is that derived? Why is that chosen?
That's a very good question. As I understand it, like they say, that's the watering hole. People will be studying that anyway, right? For mapping of the cosmos, and extraterrestrials would too. And if they put a signal next to that, then it would be visible. Is that a fair assessment, Ray?
Yes, that's very good. Hydrogen actually transmits at 1.420405752 megahertz or gigahertz. So, and so it's an actual fine line. And so what we do is we watch the Doppler shift of that line and looking at the arms of the Milky Way, et cetera, and we can tell whether the area is coming at us or going away from us because of the Doppler shift, either high or low. And so it's a very important frequency. It's the strongest of all the lines. And since the universe is mostly made of hydrogen, it is very strong. At least it's strong in our terms, but in your terms, it would be far less below any noise level you have. So it takes a pretty good size, a pretty quiet receiver to even receive it. But I do it here at my house on the 3.7 meter dish, and I do it every day, all the time. But anyway, it is believed that because the noise below about a gigahertz actually increases, that's the atmospheric space noise, et cetera, increases, and then it comes down to the lowest levels between about 1 and 10 gigahertz, and then it rises again. Then you get into oxygen problems and water vapor and all that kind of stuff. But down in this range is where people surmise that everybody else is going to have radio telescopes looking out there too. And this is kind of the place where everybody would gather. That's why we call it the watering hole. And so anyway, 1.420406 is the frequency that we tend to be around.
Does that make sense?
Yeah, I'm trying to get this to work. So what is it? that you would hear or see that would make you go, oh, ET's trying to call?
Well, we introduced you a little bit ago to Skip Carilli. Skip is the guy who's actually doing that, and he down converts the energy down to just about baseband or at baseband, and then he has a computer and a picoscope, and the picoscope is sampling that data all the time and looking at it in basically about 3 hertz bandwidth buckets, and he's looking at the narrow area right around there and looking for something that actually is statistically significant in little noise bursts. And he believes that he has found those things, and so he gave us some money to get ours operational, and we do it in conjunction with him. But basically, anything except this hydrogen line frequency, most everything else is just plain noise buried in noise. But in this one, it's an actual discrete frequency, and so it's a little bit easier to detect. But anyway, he's looking for something making sense. You know, we humans tend to do things at an exact frequency, and we also tend to do things in timing and things like that, whereas noise from space would not be that way. And that's how he's kind of trying to look at deciding whether we've actually seen something. He's looked at a number of sites in the universe, or at least in the Milky Way galaxy, but so no, right up to this time, no real significant reproducible things.
Okay, very good. Thank you.
This is kind of the proofing of the simultaneous synchronized signal detection between the 2 observatories. This is the blue line's Haswell, and the I guess it's an orange line, a green line is Green Bank, I think the red line. And this is an object that's fairly narrow, MJD 58346. And this is the hydrogen emission from that object as it drifts through the field of view of both telescopes at the same time. So you got time on this axis and amplitude on the other. And so that shows the 2 telescopes picking up that object at the same time. Incidentally, we just discovered that our pointing system has been in error. And so we have a pointing error that would cause this to be slightly off in time as these things drift through. And so we're going to correct that and go back and do some other work with Skip and see if we can correct that. But that kind of gives you the idea, 1,200 miles apart, we see the same thing. Then there's the H1 or hydrogen line emission. This is the emission Ray was talking about at 1.420406 megahertz, plus or minus 600 kilohertz. We have a device called the SMPTE-SBE48 receiver, and it's a very specialized receiver that centers on that 1420-406 and just looks at the plus or minus 600 on either side. And here you can see that if it's on the left side, it's red shifted, and if it's on the right side, it's blue shifted. And so this is a emission line from I don't know what this is actually from. It tells us there, but that's the kind of display we'd see from the SMPTE-SBE receiver. So we have pretty significant signal to noise. This actually reads out in volts. So this is 10 volts that we get after amplifying the signal. And I don't know how much amplification we have on the system. We've got about probably about 45 dB of gain, and I don't know what this had on it. Ray, do you remember?
No, but when we come from the levels of the noise level up to we amplify many millions of times. It's it comes into just as a few nanovolts, and we take it up to 10 volts.
Yeah. So that shows you the hydrogen line emission. And if we see an object that is, if this is flattened or shifted one way or the other, we can determine the spin rate or the or the Doppler rate of that object coming towards us or moving away from us. So things like a galaxy, if we're pointed at a galaxy, we'll see emissions on both sides of the center line. And what that is the arms of the galaxy moving away from us and the other arms of the galaxy on the opposite side moving towards us. We can actually profile objects that way. And each object we look at with the SpectraCyber has a different profile. And you can actually recognize objects by the profile they create on the SpectraCyber plot.
Yeah,
Here's,
Bill, there was a question there. Did you want to get it on the chat?
oh, yeah, go ahead. Is there a question? Is it in chat?
Yeah, it had to do with the synchronization of the two sites. Do we do it in real time, or do we store the data and then let Skip disseminate it?
Yeah, we store the data. We have GPS time clocks at both sites. The timestamp is recorded along with the signal amplitude. It's recorded on the disk of the computer, and then we pack up the disks, and or in this case we sent sticks, actually USB sticks, packed up and sent them back to Skip. And Skip has a very powerful computer that he's built just for this purpose, and he marries the two signals together and then gets the plot and looks for anomalies that happen in both locations. So it's not done in real time, it's done as a post-process. This is another thing we've done with the hydrogen line reception. This is a graph of the galactic longitude on the x-axis, and on the y-axis we've got the galactic latitude. And so you got latitude, longitude. Now this is the galactic, not Earth latitude or longitude or orbital latitude or longitude, but the galactic latitude and longitude. And then the amplitude is in color. So as the Milky Way crosses over us, what we end up is the hotter colors on the plot. And so this is a very crude thing, but it's the first time we've ever done a galactic density mapping with the telescope. And the professionals make very detailed contoured charts like this, but this is pretty impressive considering what we've got to work with. Let me move to pulsar detections. So pulsars. Pulsars are spinning neutron stars with massive magnetic fields, and they generate sweeping beams of broadband radio emissions as they spin. And with our equipment, we can't really hear them, but we can plot them. And with some post-processing and some specialized software, we can pull these pulsars out of the noise. They're deep in the noise, and it's very difficult to hear them. Only the strongest ones would we be able to amplify and hear. But so a neutron star could have a diameter of only about 12 miles, but it could have the density or the mass of 1.2 to about 2 times the mass of our sun. And so these are very dense objects. The only thing denser than a pulsar is a black hole. And so they're made, all of the nuclear structure has been stripped from the elements in the pulsar, and it's strictly neutrons that are in this object, and it's very, very massive. Here's a video of capturing one of these with the specialized software. We'll sit and we'll dwell on a point in the sky, tracking it for a period of time, sometimes hours, and then we do a quick post-process on that. And this plot on the computer here that Rich has will tell us whether we captured a pulsar or not. So
hey, we got it. You got it? Where? Look, right there.
There you can see the
Oh, wow, that's fantastic.
Yay! This is B1508 plus 55.
New pulsar.
Yep.
September 12th, 2020. Deep Space Exploration Society, Plishner Radio Telescope. Excellent. Way to go. This is number 9.
Hey, we got it.
You got
So there you go. That's number 9. I think in the here's a series of plots of different pulsars. They also have profiles and signatures, and each pulsar looks different. And you can see them here on these plots from the software that we use. Let's see, and they all have different periods. Like you can see here, here's a 714 millisecond, 253,187 millisecond periods, and they can go all the way from in the seconds all the way down to in the sub milliseconds in speed, and that's their spin rate. So far, I think we've captured 13 pulsars. Is that right, Ray?
Yeah, 13 right now, and we have had quite a dry spell here for a number of months, but we're starting to pick back up on it again and getting things straightened out. And I think we'll probably heading toward maybe 100 before we're done.
Yeah, we're right now we're 5th in the world for amateur groups and detecting pulsars. So 13 puts us 5th in the world. Now I think the next guy up is Joe Martin, who wrote the software, the GNU open source software to detect the pulsars. And I think Joe has what, 50? Something
Yeah,
like
I don't remember how many he has, but he's in our sites.
yeah. So he's not too happy with us that we're gaining on him. He's down in where is he? He's in just over the Colorado border in New Mexico.
Yeah, he's in Espanola, which is kind of north of Santa Fe.
Yeah. But he's doing it all by himself. He's got a radio dish and pretty impressive equipment. Okay. Any other questions on any of that before I go on? All right. So amateur radio. We also have amateur radio capability. So we can do the original tropospheric scatter that the site was intended for. And Ray has done some of that. And we've gotten several long distance contacts over the horizon. We can do EME or moon bounce. And we reflect the 1296 megahertz signal off the moon. And I'm going to show you that in a minute. HF radio, VHF, UHF, microwave, short range, and tropospheric, and 1296 and beyond. So far, we haven't really done too much above 1296, but that is the intention, I'm sure. Here's our radio station. We designated it K0PRT for Plishner Radio Telescope site. And we've got a tip-over tower that Ed Korn built for us, and it works really well until it breaks. The last time I tipped it over, it broke, and we had fun with that. But we can lay it down and work on our beam, and we need to do that because the winds are so strong out there that the elements on the beam get twisted around quite often. Right now, I think our rotor might be broken, and the rotor's not breaking well, so probably wrapping the coax up. And so on this antenna, we've got the stick on the top is our talking radio stick at 146.46. And then we've got the tri-band beam, and there's a number of other antennas hanging off of this tower. And we've got a small vertical here on the ground, and I think it's a 4-band vertical, and that's our bench for the ham radio station in the bunker. So EME, we've done Earth-Moon, Earth communication in contesting. Here's Ray putting the 408 feed up, getting the radio set up for it. Actually, 1296 feet, excuse me. And then we've got the tracking computer that tells us where the moon is, and we can track it. And I'm going to show you, if you've never done it, it's remarkable, and it really captures your imagination. I'll show you. This is Myron Babcock. He's going to call CQ, and you'll hear his echo.
CQ, K0 Papa, Radio Tango, Delta Mike 88, Colorado.
Got somebody?
No. Hello, CQ, CQ, CQ. K0 Papa, Radio Tango. K0 PRT. K0 Papa, Radio Tango. Delta Mike 88, Colorado. Over.
Okay, so what you're hearing there is the 2.5-second delay of the echo off the moon at the speed of light. And so that's pretty exciting when you hear your own voice. And it's difficult. We're one of the few sites that we can do a single sideband. Most people just do CW off the moon. But since we can do single sideband, it's pretty exciting to get that. This next one is Gary's making a contact with California.
Whiskey 6 Yankee X-ray, Whiskey 6 Yankee X-ray, Kilowatt 0 Papa, Radio Tango. Kilo 0 Papa, Radio Tango.
I'm going to truncate that and go to the end, which is more exciting.
Stanford University. Roger, copy Stanford University. 73. Whiskey 6 Yankee X-ray, Kilowatt 0 Papa, Radio Tango. Clear.
Now, one thing you might notice is that when Gary talks, you don't hear his echo as well, and that's because of the pointing. So we have to do a lot of calculations to find out where we are in the orbit and adjust the Doppler offset to get it to talk to the moon. And so sometimes, like when Myron was operating, he was directly on the moon, and so his offset was near zero. So what he hears coming back is almost the same frequency as what he transmitted. However, if we're transmitting across the span and across the orbit, then you have to compensate for that and adjust the frequency to handle the Doppler effect. So what you hear in Gary's isn't quite as clear from his own echo as what you heard in Myron's. And that's complex. You have to almost have a computer program setting you up to do that. Any questions on EME?
Yeah, Bill, do you guys publicize what you've got going on here to some of the other ham clubs and ham groups, and maybe offer them an opportunity to come and operate the station in this manner, that sort of thing? Obviously with supervision and help, but do you let other hams know about some of the facilities that are available for this?
Oh yeah. Well, one of the things we do, and I'm going to talk about that a little bit, but we do an annual open house. So that's coming up on August 7th, so 2 weeks away. Okay. And so we invite all the ham groups in the area to come down and see what we've got, and everybody's welcome to play that day and fool around with it. And if they're so inclined, they might join. We've had a number of people join the group. I think right now we've got about 50 members, and there's probably 15 core, what I'd call core members that maintain and rebuild the site. But we've got a number of people that have been very interested in doing some of these things in radio, and they're sure welcome to join.
Send me an email. Ray has my email address with the information on your open house and everything, and I will forward it to our SkyHub link email list, which is 250, 300 strong at this point. So send me that information, and I'll make sure that that gets out, and we'll also announce it on our Monday Night Net here over the next couple of weeks.
Okay, that'd be good. Ray, do you have the brochure that Myron sent out?
No, not with me right now.
Okay, I'll send it to you, or I can send it to him direct. But yeah, we did a little blurb on it, and we've got what we're calling a brochure, but it's actually just a paragraph, and it tells what it is and where it is and how. And I need to add a map to that, and then send that out to some of the ham radio groups. The site is a
Yeah,
little difficult.
I do have that. I could send it.
Okay, yeah, maybe we can send them a Google Maps link as well, so they can find the place. It is literally in the middle of nowhere.
Sounds like a great motorcycle ride.
Oh yeah, yeah. Unless you have bad weather, and then you don't want to do that. We do optical and radio astronomy demonstrations during this open house, and so we've had a number of telescopes out there with filters, so we can do solar observations during the day, and then we'll do deep sky observations at night with some of the telescopes. And usually, people bring out a lot of stuff, and so we've got a lot of demonstrations and things going on. Rich Russell, our science guy, is planning on doing a certification process on this open house, where if you're a member of certain groups, the Sarah group and the Astronomical League group, you can get certified in various aspects of radio astronomy. And so what we're all trying to do is get silver or gold certified in doing some of these things. That involves building a small telescope, observing certain things, proving that you can. It doesn't go as far as pulsars. It's mostly just hydrogen and a few other pretty minor things, maybe radio Jove. But we're going to get some people certified with that. We also sponsor awards in the Pikes Peak Regional Science Fair and the technology fairs. We do publications on radio and radio astronomy in the Society of Amateur Radio Astronomers. We do site trips to the National Radio Observatories. I've gotten to go, since I've joined the group, I got to go to the VLA in New Mexico and to the Green Bank Observatory in West Virginia. Some of the guys went to the Arecibo telescope before it fell. And so it's an interesting group to belong to. So our website with all of our proceedings, articles is open to public. It's just DSES.science. You don't even need the HTTP. And we do mentorship of student participants. Here's some of the pictures from one of the previous open houses, where we've got the optical telescopes out doing some solar observation. We've got what's called an itty bitty telescope made out of a dish network dish, looking at the sun. We have usually we have breakfast on Sunday, and we have a hot dog dinner on Saturday night. So people come out and we all sit around and talk radio astronomy and radio. This is crowding inside the control room of the communication trailer. These are some of our student participants, the science fair. This is Andrew Duvall. He took our data and did some post-processing on it and did a really nice science fair project, took it to state and won some pretty big state awards. Here was a young man, Hans Gainsborough, and he took an SDR, a SDR dongle, and he said, I don't like the way that is. I'm going to make that better. And he re-engineered the SDR dongle to add additional stuff to it. And so he got a standing ovation at the Sarah Western Conference, and he was only 17 at the time. And so we were real happy about that, and we sponsored it. We'd like to get more students to sponsoring this sort of thing, get them interested in the sciences and engineering and what we can do with this sort of thing. Here's Rich Russell. He's got set up to do the radio astronomy education certification program. And then we do public outreach. We're down in a rural area, and we don't want people wondering what we're doing. Are we, what are those guys doing down there, right? In my opening. So one of the things we do is we go down to the local bazaars in Haswell and Eads and the local area, and we get as many of the locals to see what we're doing as we can. A lot of times they're kind of standoffish. What are you guys? Why are you here? Why are you in this bazaar? And so we pull them in and we say, yeah, here's what we're doing. It's an organization and we're trying to do these things, and it makes them a little less suspicious of what we're doing in their area. And then we have the Society of Radio Amateurs. They have two events a year, usually one in the east, one in the west. And here was one we held in Boulder 2 years ago. And we do some papers in those and meet all the other like-minded radio amateurs for radio astronomy. So we have, if you're interested in this, we have an engineering and operations meeting every second Monday of the month at 6:30 Mountain Time, and a science meeting every fourth Monday of the month at 6:30 Mountain Time. Those have been done on Zoom, but eventually we're going to have them in person again, like you're doing, and we'll probably also have them online while we're doing them in person. And then we have a site work trip, a standing time of every third Saturday, but that varies depending on people's schedules. So we always ask everybody to check the schedule in the website and try to communicate who's going, what we're doing. You can join our group for $50 a year for full voting membership, and you can do that on PayPal at the website. But it's quite an interesting organization to belong to, and we're doing some unusual things. So there it is. That's all we got. Questions?
Well, I just that's an amazing thing, and I'm sorry we don't have more people tuned into this because I don't think many people know that it's there, especially in the amateur radio community. And this being a fun presentation for SBE, I'm really really a little disappointed that we didn't get more people to come and hear what you've done. You guys have done an amazing job, and I find this absolutely fascinating. Obviously, being a ham radio operator and knowing Ray for as long as I've known him. So hats off to you guys. Great job. Appreciate you taking the time to do the presentation. And I'd like to maybe try to figure out some way to do this on our Monday night SkyHub Link Hamnet. And one way we've done this before is we've allowed the guy to or not allowed, but have the guy essentially get on the radio and do the presentation while directing people over the air to a website where this whole presentation is.
Oh, that's
yeah, we've done that with our Colorado Severe Weather Watch net that we've had going on since March. And Matt K0LWC will get on. He'll have a presentation. He'll send out a link to that presentation, before the meeting, and then he'll be on there. He'll take check-ins. He'll do the whole ham radio net thing as far as that goes. But then he'll give the entire presentation by talking, Bill, just like you have here on Zoom, but actually doing it over the SkyHub Link repeater system. So I'd like to figure out how to do that with this and get you guys in front of that, because we generally have a minimum of 25 to 35 check-ins every Monday night. So let's talk some more about that.
okay. Yeah, and you're recording this. You could, I don't know if you've got a website for the group, but you could post the recording too for the people.
Yep. Yeah, we didn't mean to cut you off there. Go ahead.
We've actually posted it on our website as well. I've done this. This is the 5th time I've done the presentation, and the very first one we recorded and posted on our website. So we do have that up there.
Yeah, and Bill, where are you? Where are you located?
I'm in Colorado Springs.
Okay. Well, you're well within reach of both our Springs analog repeater and the Fusion digital. So very good. All right. Any other questions or comments from anybody else in the group? Chris, Amanda, anything from you?
No, just a big thank you for me. It was, I found it very fascinating.
Good.
Oh, okay. All right, Bill, Ray, thank you so much for your time, and we'll talk some more here. So, guys, that's it. Hope to see you at the picnic. Ray, you're gonna make it on Friday, I hope.
I'm not sure yet. I just got a new transmitter in and I'm in the process of installing it, and I'm not sure whether I'll make it or not, but I'm going to try. I'll register tomorrow if I can.
Okay. Okay, great. All right, guys, thanks for being here tonight. Thanks to Chris and Amanda so much. Chris, you want to talk about what we have coming up for the SMPTE meeting here this month?
Actually, it's kind of in flux at the moment. So yeah, we don't really have anything confirmed on the SMPTE side past the picnic on Friday, but stay tuned. As soon as we have news on that, we'll get that out to everybody.
Okay, and as usual, guys, keep up to date by checking the webpage. Amanda has done just a wonderful job with that. Amanda, thank you very much. Are you still there? Okay, I think she had some other stuff going on too, but I see her name up there on the attendees twice. So, so maybe she's listening in the background. All right, guys. Well, that's it. Have a good night. Hope to see those of you who can at the picnic. And Ray and Bill, excellent again. I thoroughly enjoyed this, and we'll let people know about you and pass the word along. Thank you very much.
Okay.